So we made it to Unit 7, which is all about rational functions. In today's lesson, we are going to be doing simplifying expressions in section 43. So in section 43, we're going to simplify rational expressions, and then we're going to include excluded values. So we're going to identify those, and then also label them as a whole or a vertical asymptote. So to start with, we need to know and recall how to factor. And when we factor, that includes GCF, difference of squares, or trinomials. So in this first one, we have 3x plus 9. Notice that both the 3 and the 9 have a 3 in common, so I'm going to pull out a 3 and then write down what's left over, which is going to be x plus 3. For number 2, this is a difference of squares. So the first one was GCF. This one is a difference of squares because both x squared and 9 are perfect squares, so we can go ahead and write down x plus 3, and then we have x minus 3. In number 3, this is another GCF. You're going to pull out a 4 and an x. So we have 4x, and then what's left over in parentheses is going to be x plus 2. Number 4, this is another GCF. Both terms share a 12 in common, so I'm going to put a 12, and then what's left over in parentheses is going to be x plus 2. For this next one, we have x squared plus 4x plus 4. This one is a trinomial. It's a quadratic. So we're looking for two numbers that multiply to this 4, but then combine to the middle 4. So that would be 2 and 2. So we're going to write down x plus 2, x plus 2. And then number 6, this is another difference of squares. X squared and 16 are perfect squares. So we have x plus 4, x minus 4. So this is all review. This next part, our notes, is what I'm going to be explaining rational functions are, and then we have excluded values, which are either going to be wholes or vertical asymptotes. So a rational expression is an expression whose numerator and denominator is a polynomial. A polynomial is made up of multiple terms. You can have it raised to the power of 0, so just a constant, an exponent of 1, an exponent of 2, an exponent of 3, and so on and so forth. So excluded values are going to be either wholes or vertical asymptotes. So it's labeled right here. Wholes and vertical asymptotes are excluded values. Whatever would make x not equal to some number. So an excluded value is either a whole or a vertical asymptote. So whatever the wholes are, you're going to write as an excluded value. Whatever the vertical asymptote is, you're going to write as an excluded value. A whole is whenever you have to cancel a term. So I'm going to put just a number. What you're going to do is you're going to take whatever you canceled and you're going to set it equal to 0 and solve. Now, why are you doing this? You're doing this because whatever number you would plug into the original rational expression, you would get 0 over 0, making it a whole. And wholes are circles in the graph. A vertical asymptote is whatever is left over in the denominator. And what you're going to do is you're going to set that equal to 0 and solve. A vertical asymptote is going to be a vertical line that happens to be a dotted line. And that vertical asymptote would mean that you have some number over 0, which is undefined. So that's why there's a vertical asymptote or a break in the graph. So what in the world are you going to be doing? You're going to be taking something like this polynomial, 3x plus 9 divided by x squared minus 9, and you're going to simplify it. So I'm going to start by factoring. I'm going to factor the numerator and denominator. And the numerator, I'm going to pull out a 3. What's left over in parentheses is going to be x plus 3. In the denominator, I'm going to factor this, x squared minus 9. This is what we did in the warm-up, in the entrance lit, both of these. And we get x plus 3, x minus 3. From there, you're going to, in order to simplify, you're going to cancel. I'm going to cancel the x plus 3 with the x plus 3. Now I'm able to cancel this because everything in the numerator is multiplication Everything in the denominator is multiplication. And we're going to be left with a final answer of 3 over x minus 3. That's my final answer. This is the simplified version of 3x plus 9 divided by x squared minus 9. So now what you're going to do is you're going to identify the excluded values. I'm going to take two things. I'm going to take the x plus 3 that I canceled and set it equal to 0. And then I'm going to take that x minus 3 in the denominator and set it equal to 0. And then we're going to solve. So again, this is what I canceled. And this is the denominator. In order to solve x plus 3 equals 0, you're going to subtract 3 from both sides, and you're going to get x equals negative 3. In order to solve x minus 3 equals 0, you're going to add 3 to both sides, and you're going to get x equals 3. So what you're doing is identifying x equals negative 3 and x equals 3 as excluded values. You would write down x cannot equal negative 3 and x cannot equal 3. Now we're going to identify them as either a whole or a vertical asymptote. There's going to be a whole at x equals negative 3. That's what you canceled. And there's going to be a vertical asymptote at x equals 3. That's what's left over in the denominator. Over here to the right-hand side, you can kind of see that there is a whole at negative 3 at x equals negative 3, and then I also have a vertical asymptote, a vertical dotted line at x equals 3. So this is a graph of the original rational expression 3x plus 9 divided by x squared minus 9. And all you're doing is simplifying whole vertical asymptote, and then you just label the whole and vertical asymptote as excluded values. All right, so on this next page, it says how to make the numerator and denominator equal. So in this first one, you notice that I have x minus 1 divided by 1 minus x. Everything about them is opposite. The x is positive in the numerator and negative in the denominator. The 1 is negative in the numerator, it's positive in the denominator. So what you can do is I can pull out of this denominator a negative 1, or a negative number. And now, by pulling out a negative, I write what's left over in the parentheses. And now that they're both the exact same, you're able to cancel them, and you're left with negative 1. So we're going to do the same thing right here. In this next one, we have 3x minus 4 in the numerator and 4 minus 3x in the denominator. If I pull out a negative 1, then that 4 becomes negative, and this negative 3x becomes positive. Even though they're in opposite orders, they're opposites of one another. Now they're the same. So they were opposites, now they're the same. Now I can cancel. And we're left with negative 1. Same thing in this next one. 5 is positive, it's negative in the denominator. X is negative, it's positive in the denominator. If you were to pull out a negative 1, 5 now becomes negative. Negative x becomes positive. They went from being opposites, now they're the same. Cancel and you're left with negative 1. So which of the following simplifies to negative 1? The only ones that are going to simplify to negative 1 is if they are opposites of one another. And that would be letters A and F. In letter C, these are opposites, but the 2x is both positive. In letter E, they're exactly the same, so the order doesn't matter. They're positive and positive. Letter D, there's a 5 in the numerator and a 4 in the denominator. So those are not opposites. The reason why B doesn't work is because in the denominator, if I were to pull out a negative 1 from this, we would have 4 plus x in the numerator divided by negative 1, and then it'd be negative x plus 4. So by pulling out a negative number, you're just changing whatever one is negative. So now I made the x negative. These are non-opposites, therefore B is not an answer. We've gone through every explanation that we would need for this lesson. In the next video, I'm going to go through all of the examples.